Hello, my name is Joseph Abel. The paper I'm presenting today is called Rethinking Access Control and Authentication for the Home Internet of Things (IoT). This paper is from the 27th Usenix Security Symposium and was first talked about back in 2018. This presentation is for the CS 6263 Cyber Physical Systems Security course. A little outline of what we're going to discuss today throughout this presentation is first, background information about what the Internet of Things is, and then we're going to discuss the problems that the Internet of Things faces in today's society and with the end users and with the developers of these products. Next, we're going to be discussing models and access controls that the Internet of Things is affected by. And then we're going to discuss these 4 questions that the authors and researchers constantly talk about throughout the paper, which leads into their study. And then we'll talk about more detail about the study, what they're doing, how they're doing it. And we'll discuss about the results of the study and how it impacts the society we live in today. And then we'll talk about the conclusion, some final thoughts about the subject matter, and what we can do ourselves in order to make sure that we have a more safer society that we live in. So, some background information first, as I said. First thing we're going to talk about is what is the Internet of Things? The Internet of Things is essentially a system that, let's say, is on a network X and has, let's say, I'm trying to connect to a surveillance system on my phone. I can access the application on my phone and I can log in and I can view all the cameras that I have set up from a remote location and I can monitor them that way. So that's kind of an Internet of Things device and it's an embedded device that has hardware and software combined in it and uses that can exchange data over the networks between multiple nodes. So in this scenario, I can exchange data between my phone remotely and the camera itself from wherever it's located. The next thing that we need to discuss is what authentication is in the sense of our Internet of Things. So authentication in this sense is the same definition as it is in other senses, essentially, where we're discussing, are you who you say you are, and do you have access to log into this account? Can you provide a password and a username, or can you provide a 6 to 10 digit code with your email and say you are this person? So that's kind of what that is, almost like when you log on to a regular computer, you're proving your identity to gain access to resources. Talking about resources, this leads us into another option called another definition called access control. Access control is when you define certain resources for different users on your system. So if we talk back about the camera example, for different users, I may have different properties where, let's say for user X, they might be only able to have access to camera 1 and 2. But if I'm the main security guard there, I might have access to all the cameras on premises. But meanwhile, the manager might only have access to the cameras in his building. So that's what access control is. What resources are tied to your account? What can you see? And what can't you see? So these 3 concepts tied in together because we first need to create an account and authenticate ourselves to the system. Once the system is set up, we can create, we can give ourselves, we can assign certain privileges to ourselves on the system from, let's say, an administrator, and they can delegate to us, you have access to this, you have access to that, you don't have access to this, you don't have access to that. That is the access control on our system. Then the Internet of Things is the actual camera itself, if we're talking about the camera example still, So maybe on user X, like I said, I have access to two cameras, and I can access those two cameras on the network X, and user A is looking on network X at those cameras and only has access to those two cameras. So let's talk about some problems with Internet of Things that's discussed in this paper. The first thing that the researchers talk about are poor software engineering practices, and when they're referring to this, they're referring to poorly written code and not reusable code for different applications, or code that's not easily understood or unsafe for the application. And when I say unsafe, I mean code which can lead to security vulnerabilities such as cross-site scripting, SQL injections, etc. So that's one of the core problems in Internet of Things, but the paper more so talks about how there's little to no attention in the realm of access control to these Internet of Things devices. There, for a resource or an access control list on the device, like let's say, like I just said, who has access to what camera, it could be a very I gave an example that was more detailed, but in most common Internet of Things devices, there could be only a binary option. Either you have access to everything on the system, or you have access to, let's say, nothing on the system. So it's all or nothing. There's no in between and assigning access and privileges to different users on certain Internet of Things systems. And we'll see this more common in different examples throughout the paper, but that's what they're talking about. Also, in some cases, there are certain applications. So, if we talk about now, like a Google Assistant or an Amazon Alexa or an Amazon Home device, the device might have access to a lot of third-party apps or features, and a lot of security researchers and privacy experts are saying that these devices are overprivileged and really shouldn't have all these accesses because it's gaining so much trust and access to different parts of the network and system that the application really doesn't need it and could be abusing its rights on the network. So that's another problem that a lot of um, people are talking about. So this kind of ties in back into access control because we're saying, as a user on the system, do I really need to have access to all these capabilities and do all these different things on this Internet of Things system? Another problem that's being stated is also back to authenticating or verifying users. On a large scale Internet of Things system, you might have millions of users, and they were talking about how are you going to scale for each user in your home and each user, not to mention each user in the world, we're just talking locally, so each user in your home. You could use a IoT authentication framework. There's Kerberos frameworks and LDAP frameworks, but those have a lot of constraints. And we're not going to really touch on those constraints for this paper, but we're going to talk about a different authentication method, which is introduced in the paper. Let's say we use an Amazon Alexa device or a Google Home device, and we want to gain access to our account on that device. There is a new upcoming technology called vAuth, or voice-based authentication for voice assistants. And this type of authentication protocol requires the use of a wearable hardware or a different device or a device like that's nearby that essentially can establish an authentication channel to a certain system. And when I say wearable device, wearable hardware, it means basically hardware that is both on you like a cell phone or hardware that's just close by to you. Um, Also, one of the goals also throughout this paper is to use that voice user authentication to to have different users access certain access controls in your house. And when I say that, I mean, as if I have 4 users in a family, user A, B, C, and D, I can use the voice-based authentication service, and each of those 4 users will have different access controls. And these access controls might limit each user to only doing certain things. So if I'm a child, I might not be able to purchase anything using the voice-based authentication. And if I'm an adult, or if I'm a husband or a wife, I might have access to purchase different things on the voice-based authentication system. Next slide. Okay, so some models and rethinking of access control that we're going to discuss and that the authors discussed throughout this paper are the concept of device-centric models, where access is granted or denied per device. So basically, it's a binary decision. You have access to it or you don't have access to it. Or a more capability-centric model where access control is used. And a capability, as I've kind of alluded to before, is essentially, do you have access to this part of the system? It's an access control list or an access control, essentially. So it goes back to the idea of, let's say, a camera again. I have 10 cameras. I might sign in as user X or user A, and I might have access to only 2 or 3 cameras and not all the cameras. So that's kind of the capability or access control list part coming into this paper. Also in this paper, the authors and researchers discussed 4 core points, and I've summarized them into 4 questions below. The first question is the desired access control policy for different capabilities of or on a device. The second question is the desired access control policy for different participants using different devices. The third question is the contextual factors and access control policies. What do these depend upon and factors? So this question can sound confusing. Essentially, we're saying, do the capabilities you get as a user, is it dependent on the amount of usage? Is it dependent on your age? Dependent on the time of day or the location? The fourth question is, what type of authentication methods can balance convenience and security for the IoT? It's not asking here different frameworks or software for authentication. It's asking about false positives or anomalies that you might have in a system for Internet of Things, and are they good or are they bad? So let's get more into the research of the paper and what's behind all of this. So before we get into the study, we should also note, well, I should also note, that there was a pre-study before the primary study, which was able to narrow down some capabilities and categories, which we're going to discuss in the presentation. So the primary study narrowed down 24 categories of people to only 6. That's what the pre-study did to the primary study. In the primary study, the people we're going to be discussing is the spouse, the teenage child, a child in elementary school, a visiting family member, a babysitter, and the neighbor. Also, we narrowed down the capabilities to 22 capabilities. These are based on a variety of different Internet of Things devices, such as voice assistants, cooking devices, and even home automation devices. That's what the primary study is going to focus on. And we should also mention that in the appendix of the paper, they mentioned how they used an online survey method in order to gather results. And they were able to gather textual results based on whether or not one of the participants in the primary study, there were 426 of them, if one of those 426 participants would be okay if, for instance, a certain capability or feature was executed by one of the 6 people I described above. So let's say we have participant 130 and they were a babysitter. And let's say the babysitter was able to have access to, let's say, lock and create different people who can lock and unlock the smart lock on your door to get into your house. Would you, as a participant, always be okay with this, never be okay with this, or sometimes be okay with this? Those were the options, and then they need to provide a written justification as to why they chose that option. Personally, I would never be okay with the idea of a babysitter controlling a smart lock, but everyone's different. So, those were the options. And another option would be, okay, the babysitter again, how would you feel as a user if she can control the lights in the house? She could turn them on and off. Would you be okay with that always, sometimes, or never? You can pick your option accordingly, and that was what the survey did. So the capability in these situations are the light or the smart lock, the smart light or the smart lock, and we're saying, would you be okay with that in the scenario of one of those 6 categories of people was able to do that? That's what they asked the participants. And so as we get further down into the study, we were able to see that they would answer if they were positively were okay with that capability or negatively okay with that capability. They would provide said justification, and then the researchers would evaluate their responses, and they were able to pool together a select amount of responses or based off of 22 different capabilities, and this is going to lead into the results, but there isn't something else that we should just discuss. That after they were given these questions and specified about access control policies for the given capabilities of the IoT devices, they also asked about the demographics of the people and the amount of people in said houses of the participants and the number of bedrooms inside there, etc. And the reason they asked this is because we're going to see that in the results of this study, these factors play an important part because, as we're going to see based off of the 4 primary questions we answered, if I'm in a house with a spouse and I have 2 or 3 kids and they're all about the same age of 5 years of age, that's going to make a difference in the demographic of my house of what access control properties I delegate to these elementary based kids and what they're going to have access to. If I gave them an account, you're not going to give a 5-year-old or 6-year-old kid access to purchase anything they want off of an assistant, a Google Assistant or an Amazon Alexa, because then they can keep charging hundreds and hundreds of dollars worth of merchandise. I'm also not going to allow a child of young age to constantly have access to the lights and be able to flicker them on and off whenever they please. There would be a limit on that, or the privilege would just go straight to the adult. So this is kind of the idea of access control and what we're doing and what the study was primarily trying to indicate to different people. Is it okay in those one of the 6 categories that we described? Is it okay if you had this property and you were able to do this certain type of feature over and over again or anytime? So the results of the RQ1 question and some of the participant data shown below, we can see that the study has 426 responses, but only 425 were included. One wasn't counted because it didn't appropriately answer the short response questions. The study was generally gender balanced, as indicated in the paper. The most popular age range was 25 to 34. where 27% of the people lived in a two-person house, 23% in a three-person house, 20% in a single-person house, and 17% in a four-person house. We also, in the paper, there was discussed for the RQ1 study, of course, about the percentages of capability differences, where if you would want your babysitter, let's say, to use your voice assistant to play music or order things online using your card information or another form of information. And besides that study, another interesting study that I want to get to in the RQ1 answer was that, in contrast, about 76.8% of the participants said they would, and this was, I should just reiterate, the RQ1 study is like the results of the capabilities that you would allow the 6 categorical people to do to your smart home, essentially. So besides going through all the data, we're just going to go through some of the key points of data and some of the security mechanisms in the house that were really stood out. So the first one was if you would allow the person in your house to delete the activity logs or what they use from a smart technology point of view perspective in your home. So I basically, like, if you were to turn on the light, it gets logged in the computer or on your app. And if I was able to play music, would you allow the person in your house to delete these log files, the activity logs? 76.8% of the participants said they would never allow this. And it makes sense because you wouldn't allow someone in your house to be able to do this because you don't know what they're doing and they can cover their tracks this way. It's almost like an adversary trying to get unauthorized access into a system and then quickly covering up their tracks so you can't find them through footprinting and enumeration. So that was an interesting result that I thought that should be shared. And another one was answering a doorbell. Most of the participants said that sometimes, depending on the context, they would allow them to answer the doorbell, whoever was there, most likely like a babysitter or another user. But at the same time, about 25% of the participants said, 25.6% of the participants said that they would never answer the door. But this is interesting because this kind of relates into a social psychological experiment, because the minute you say a homeowner is present, like a spouse or someone else who's the homeowner, it plays a key role or factor, and all of a sudden the statistics change, saying essentially that if there was, for instance, like a babysitter or a young child home, about 66.7% of the people would then choose sometimes they would answer the door, and they would have about, if they saw on, like, let's say then a security camera that a delivery person was at the door, the babysitter or another person would be 77.8% more likely to answer the door than if there was not a homeowner home. And this is despite that if there was a delivery person there and the homeowner wasn't home, these statistics that are in the fourth bullet still apply. The statistics I'm saying now only apply if a homeowner is home. And also they said that some participants, about 16.7%, would consider giving access to their neighbors while they were away on vacation for a temporary amount of time. If there was an emergency, they would allow them access. So the RQ2 results essentially say the permissions, the default permissions that you would give to the 6 categorical people as described earlier on. More specifically, the part I want to look at is with the spouse, which I think is interesting. But before we get to that, I just want to make note that on the right-hand side, you have the RQ2 results, and these results are basically the default values you would have in a smart home according to the study, while on the left-hand side, you see a general overview about some of the statistics with spouses. So let's just dive right into it. About 93.5% of the homeowners said that they would give full access to their spouse for them to have the same privilege as them. And this is mainly because they said, okay, we're married, we can trust each other, you can have the same privilege that I have. Meanwhile, 4.15% answered sometimes, and 2.35% said never. And this is because they didn't want them having control of the smart lock log file. And in case you're not sure what that means, it means a smart lock on the door, having and seeing who's coming in and who's coming out, and at what time you're coming in and what time you're coming out, etc., and the day of the week and the date. So just an interesting thing to observe. Another thing that we should know is that on the right-hand side, as I said, they have the default values that would come in a smart house, and it says for the spouse that they should always have access to all capabilities except for deleting the log files. This is because the first bullet's not 100% true, because they don't want them to always have access to the same capabilities as the house owner, which is a very interesting thing to view. And as you can see, the second bullet says no one except a spouse should unconditionally be allowed to access administrative features. And then we have the other bullets like children, elementary school age children should never be able to use capabilities without supervision. And for visitors such as babysitters, neighbors, and visiting family, they should only be able to use capabilities while in the house. Never be allowed to use lock doors and cameras in the house because that's for administrators. And should only be able to adjust the lighting and temperature. So we're giving them really guest privileges, like as if this was a computer. You have the regular user, you have the guest user, then you have the administrator and super user. So that's kind of how this is being carved out into. And it's pretty interesting if you look at this data and you look at the default permission values you would give them. And another thing I just wanted to mention was that ordering online was kind of limited to spouses for only 78.9% of the time. And really, the other 84% of the time, it was limited to the owner of the home. This was based on a split sample study of the 426 participants. Well, really 425 participants, but it's just interesting to see that divide difference and how come it's like that, because you have 79% who are the spouse and the homeowner trust them, while 84.2 said no, just the homeowner should have access to this and not the spouse. So the RQ3 result is basically the factors that we were talking about throughout this project. There's 8 of them. It's age, location of device, your recent usage history of the device, the time of day, the location of the user who's using the device, costs, people nearby, state of the device, and a few other factors, but they were kind of minimal and weren't as heavily taken into consideration as the others were. The top 3 concerns of RQ3 for the RQ3 question were age. The reason age was in there was because it allowed young people to have certain capabilities who might not be mature enough to have such as a privilege. Like I said earlier on, would you give a 5 to 7-year-old privilege to the voice assistant and access to your card information to potentially place a large order on an online merchandising store website? I'm not sure. I mean, it really depends. Would you want them to have access to your smart gardening equipment if you had that for home automation? I'm not sure, like I said. So really, that was the top concern. That's the number one concern for the RQ3 question. The location of the device was the second most frequent, and it was a factor for which location should you have access to, and this kind of ties in with RQ2, where can a normal user have access to see the cameras if there were them in bedroom and bathrooms? Or would this be only for the super user and administrators? Can they only see these? Because they're very private rooms. So the location of the device determines does the user have access to see this resource? Also, another thing that was noted was the recent usage history. Is a user abusing their capability? So, for instance, if I have a 7-year-old son or daughter in the smart home, are they constantly saying, turn off and on the lights, turn off and on the lights? And I can see it on the activity log. They might be drawing a high wattage, and all of a sudden, I could see you're abusing the privilege. I'm going to revoke your privilege now. And now, as the child, you don't have access to turn on and off any lights, or can I limit it? So, or is the same thing with purchasing? Are you purchasing a lot of items on the network? I'm going to limit you now on the IoT voice assistant, so now you can't order any items. The fourth factor is the time of the day. And basically that means, would you have an home automation device, let's say a smart lawnmower, would you have it go off in the middle of the night at about 11 p.m.? Well, most people would say no. You wouldn't want it to go off in the middle of the night. That's silly. Would you want to have a child to have access at let's say 12 a.m. to access the smart TV? No, you wouldn't. The child should be in bed. They shouldn't have access to the smart TV. So that's what the RQ3 results really say in summary. The RQ4 results are a little bit more interesting, and these results analyze how you would feel if basically the availability of a system was compromised or there was a false positive or false denied decision. So I kind of labeled here a few statistics. The first one says if a neighbor was able to, let's say, have accumulate access to a certain part of your system, let's say, would you be okay with that, or would it not be? So 64.1% of the people said if a suspected neighbor accumulated access, it would not be convenient to them. And this can mean that they have access to their security camera, their smart door, or a different authorization system, and that didn't maybe work as expected. They didn't like that if a neighbor could get access that way. So basically the system thought you were someone else than you said you were. People said, kind of piggybacking off the last bullet, that 100% of the time, if a neighbor could somehow remotely disable or enable a security camera or a door, a smart lock, they would completely inconvenience them almost to 100%. The smart lock was 92.9%, but essentially overall the consensus is they would not be okay if you could tamper with a security camera or tamper with a smart lock. Which makes sense. This is large amounts of confidentiality issues, integrity issues, and availability issues within the smart home. And also, the last bullet kind of ties in to RQ3 about the capability rights, and said that would you allow, it relates to children, saying, would you allow if any child or the child in your home or in a different home could order something online or remotely start your smart gardening devices? And 79% of the people said they would not be okay with this if they could order for them or start a gardening device for them, which makes sense because then you could start it whenever you want, and again leads to that privilege problem and basically access control problem of who's really controlling my devices. So the conclusion, basically, the data shown in the RQ1 shows that desired policies can vary pretty widely within a single device or home based on the relationship of the 6 category of people that it could have access to, which is pretty interesting to see based on the statistics stated beforehand in the prior slides, while the data for RQ2 suggests the default policies are simple. Some are not really quote-unquote IoT policies, as the paper suggests, where you might have access to do a certain task, but the end user could be kind of lazy and not want to do the task. This is kind of like you wake up in the morning and you might not want to make coffee, so you might have your smart device do it with the push of an app. They consider this a quote unquote non-IoT policy, and they think if you want this done, you should be in kind of somewhat in a remote location or not within proximity of your house. So just kind of something interesting to see. Um, and the next thing is in RQ3, the data suggests that the factors are dependent on contextual stuff such as age, usage, your location, and other services. Are you using it a lot? The time of day. So these factors play a role in whether or not you're going to have a current system running, and at the time of day, who's running it, why do they have access to run it, can they have access to run it, and can we trust them? And lastly, RQ4 data basically saw the most frustration if people saw how it would be if someone was frustrated with the system, if it was compromised, when the confidentiality, integrity, or availability of a home system or a gardening system had a problem, what would happen then to the user and how they would feel about it. And as we saw from that study, it was not a positive and mainly negative, and they felt highly inconvenienced. As this presentation is wrapped up, I just want you all to think about how our digital society is run and how Internet of Things is slowly taking over the world we live in today. And we need to think about how we can make the society that we live in a safer place and a more privacy conscious place that we live in, so all of our data is not available on the web. Thank you very much, and I hope you all have a great day.